Hello students and good morning. So now I am doing class for class 12. The topic is the same topic that we were doing in the last online class, that is integration by the method of substitution. So today is that continuation class of that chapter. Same exercise 6A, page number 351. It is of 5 marks section. So now in this case we will do some method of integration by the method of substitution. So let us take an example here. So let us take this example. So let us do this method now. Suppose there is integration of e to the power x within second bracket f of x plus f dash of x second bracket close dx. Suppose the question is like this. Okay, so this question is very important. So this type of question you may get in HS also. Okay, suppose the question is integral sine e to the power x within second bracket f of x plus f dash of x second bracket close dx. So how will you evaluate this integral now? So let us assume it as I is equal to integral sine e to the power x f of x plus this is your f dash of x dx, right? So in this case you should know the relation between these two functions, that is f of x and f dash of x. So you should know what is the relation between these two functions, that is f of x and f dash of x. So you should know the relation between f of x and f dash of x. So what is the relation between f of x and f dash of x? That is f dash of x is the differentiation of f of x. Is that clear? यो f of x को differentiation के हो f dash of x हुँदैछ यहाँ. त पहिला हामी के गर्छौं, यो e to the power x ले पहिला मैले z suppose नगर्ने एकछिन. Don't assume z here. First of all, let us multiply these two terms by e to the power x. So therefore I is equal to integral sine within bracket e to the power x f of x plus e to the power x f dash of x second bracket close dx. So I think you have understood it. You know that the differentiation of f of x is f dash of x. Don't assume f of x as z here. First of all, you have to multiply these two terms by e to the power x and we got this expression. Now you have to assume this first function as z because differentiation of the first function is the second function out here. So let us assume this whole term, that is for the first term it is e to the power x f of x. Let us assume z is equal to e to the power x f of x. So let z is equal to e to the power x f of x. Is that clear? So now this is the method of substitution in this case. Here the differentiation of f of x is f dash of x. So we have multiplied both the terms by e to the power x here. So we can assume now z is equal to e to the power x f of x. So that is the method out here. Okay. So let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So it is dz by dx is, you can use UV rule here, isn't it? You know what is UV rule? एउटालाई differentiate गरेर अर्कोलाई same राख्दै जाने. So let us differentiate e to the power x first. What is the differentiation of e to the power x? E to the power x. F of x is kept as it is plus, now e to the power x is kept as it is into, now differentiate f of x with respect to x. What is this differentiation? It is f dash of x. That means we are getting this term. So now let us cross multiply it. So it is dz is equal to within second bracket e to the power x f of x plus e to the power x f dash of x second bracket closed. So it is dx. Now it is cross multiplied. Okay. So now let us put these values in I. So what does I become now? So therefore I is equal to integration of. So now what is the value of this expression? What is e to the power x f of x plus e to the power x f dash of x dx? It is only dz. So here we can write dz. You know that, isn't it? What is the value for e to the power x f of x plus e to the power x f dash of x dx, which is equal to dz? So it is integral sign dz. So or I is equal to, what is integral sign dz? That is your z. Since it is integrated, so it is plus c. So I think you have understood it. Or I is equal to, what is the value for z now? Here the value for z is e to the power x f of x. So it is e to the power x f of x plus c. So this is the final answer. So this question is very, very important. Okay. So now you should know this method also. Now let's do another problem from the book. So now let us do this problem from the book. That is question number 10. That is from 5 mark section, question number 10. So you have to evaluate this integral. That is integral sign e to the power x within bracket 1 upon x minus 1 upon x square dx. So let us write here I is equal to integration of e to the power x within bracket 1 upon x minus 1 upon x square dx. Okay. So we can use the same method as we have done in the previous problem. Okay. So let us check the relation between these two algebraic functions. What is the relation between 1 upon x and minus 1 upon x square? You know that differentiation of 1 by x is minus 1 upon x square. I told you to write down directly the differentiation of 1 upon x with respect to x as minus 1 upon x square, isn't it? That is dy dx of 1 upon x is equal to, it is minus 1 upon x square. So the differentiation of this first function will be the second function. That is differentiation of 1 upon x will be minus 1 upon x square. Okay, but we cannot assume z is equal to 1 by x here. First of all, you have to multiply these two terms by e to the power x. So therefore I is equal to integration of, this is e to the power x by x minus e to the power x upon x square bracket closed. Then what do we write? Dx. So you know that the differentiation of the first function is the second function. So you have to assume this first function, this whole first function as z. That is, let z is equal to e to the power x upon x. So I think you have understood it now. Okay. So let z is equal to e to the power x by x. Now let us differentiate both the sides with respect to x. This is the method of substitution. Okay. So now differentiating both the sides with respect to x. So it is dz by dx is u by v rule now. You know u by v rule, isn't it? That is the quotient rule. अब तलकोलाई same राख्छौं, denominator is kept as it is. Now differentiate the numerator. What is the differentiation of e to the power x with respect to x? That is e to the power x minus, next, now you have to keep the numerator as it is, e to the power x into, now differentiate the denominator x with respect to x, that is 1 whole divided by denominator whole square, that is x square. So I think you have understood it. Okay, so let us separate the term. Or dz by dx is equal to, separate the term, x e to the power x upon x square is e to the power x upon x minus e to the power x into 1 divided by x square, that is e to the power x upon, this is your x square. Okay, now let us do cross multiplication here. So dz is equal to e to the power x upon x minus e to the power x upon x square bracket closed, it is dx. So we have got the value of this expression, isn't it? That is e to the power x upon x minus e to the power x upon x square dx is equal to what? It is dz, right? So what is I now? So therefore I is equal to integration of, so instead of this whole expression we can put dz. Is that clear? So or I is equal to, this is your z plus c. Now let us put the value for z. What is the value for z? It is e to the power x upon x. So I is equal to e to the power x upon x plus c. So this is the final answer. This question is very important because this question is from HS question paper. Okay, so we can copy it. Now we'll do the next problem. So now we'll do the next question, that is question number 11. It is given that you have to find out the value of this integration e to the power x upon x within bracket x log x plus 1 bracket close dx. Okay, so let us write I first. Integration of e to the power x upon x within bracket x log x plus 1, then you write dx. Okay, so let us multiply it first. Or I is equal to integration of within bracket. So if you multiply them, e to the power x upon x into x log x, x gets cancels. So you will have e to the power x log x plus, then e to the power x upon x into 1 will be e to the power x upon x bracket close dx. Now let us forget about e to the power x. Okay, for the time being let us forget about this e to the power x. So it is log x plus 1 upon x is there. What is the relation between log x and 1 upon x? Log x ra 1 upon x ma के relation छ? Log x को differentiation हो 1 upon x. भनेपछि यो log x को differentiation 1 upon x हो भने यो first term लाई हामी के suppose गर्छौं? Z suppose गर्छौं. Is that clear? That is differentiation of log x is 1 upon x. So let us assume this first function, that is e to the power x log x as z. So let z is equal to e to the power x log x. Now we can easily do it. Okay, so differentiating both the sides, with respect to x. So it is dz by dx is equal to, now differentiate UV rule. This is the product of two functions. So we can use here UV rule, isn't it, or product rule. Now let us differentiate e to the power x keeping log x as it is. So differentiation of e to the power x, e to the power x log x remains as it is plus e to the power x is kept as it is. What is the differentiation of log x? It is 1 upon x. Now let us do cross multiplication, or dz is equal to e to the power x log x plus e to the power x upon x bracket closed. Then what do we write? Dx. Okay, that means it is cross multiplied by dx. That means what is the value for e to the power x log x plus e to the power x upon x dx? It is dz. That is, we have got the value of this whole expression after this integral sign, isn't it? So therefore what is I? I is equal to integral of, what is e to the power x log x plus e to the power x upon x dx? It is dz. So let us write here dz, or I is equal to, this is z plus c. or I is equal to, now you can put the value for z. Actually what was z? E to the power x log x. It is e to the power x log x plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question now. So now we'll do the next question, that is 12 number 1. The question is, you have to find out the integral of dx divided by within square root sine cube x into sine of x plus alpha. So how will you do it? So this question is very, very important. You can mark it. So let us write I is equal to integral sine dx divided by within root sine cube x into sine of x plus alpha. Now can you do any method of substitution out here? Differentiation of which function is which one? We don't know out here. It is sine cube x. Its differentiation, sine cube x differentiation is 3 sine square x cos x. There is no 3 sine square x cos x. And also the differentiation of sine of x plus alpha is cos of x plus alpha. Is there cos of x plus alpha? No. So what will you do here is, let us convert this sine cube x into sine to the power 4x. If you convert sine cube x into sine to the power 4x, then you can easily get the square root of sine to the power 4x, isn't it? What is the square root of sine to the power 4x? It is sine square x. You know that. And what is 1 by sine square x? It is cos x square x. So let us make it sine to the power 4x. So how can you make it sine to the power 4x? You have to multiply this expression and again you have to divide this expression by sine x to make it sine to the power 4x. If you make it sine to the power 4x, it should be sine x, it should be divided by sine x. If you make it sine to the power 4x, it should be divided by sine x to make it sine cube x, isn't it? So let us write here, I is equal to integration of, this is dx divided by within square root, it is sine to the power 4x divided by sine x. If it is cos cube x, then we can make it cos to the power 4x divided by cos x, and similarly you can simplify it. Okay, so then you can write here sine of x plus alpha. Is that clear now? I think you have understood it. Or now I is equal to integration of, this is dx divided by, so you can easily take this sine to the power 4x outside square root. What is square root of sine to the power 4x? What is square root of sine to the power 4x? It is sine square x, and within square root here we have sine of x plus alpha divided by, this is sine x. So I think you have understood it. Okay, so now next, or I is equal to integration of. So what will you do now in the next step? This is 1 by sine square x. What is 1 by sine square x? You know that this is cos x square x dx divided by, in the denominator, and within square root you have to simplify it. Now this is sine of a plus b. You know the formula of sine of a plus b, isn't it? From common angle, what is sine of a plus b? Sine a cos b plus cos a sine b. So here it is sine x cos alpha plus cos x sine alpha divided by, this is your sine x. It is just simplified. This is sine of x plus b, x plus alpha. This is sine of x plus alpha, means sine of a plus b. Sine a cos b plus cos a sine b divided by sine x. Okay, or I is equal to integration of, this is cos x square x dx divided by, let us separate the term here. Within square root, let us separate the term sin x cos alpha divided by sin x. Sin x gets cancelled. You'll get cos alpha plus, next, what is cos x by sin x? Cot x. So it is cot x, isn't it? And sin alpha. And it is sin alpha. Is that clear? And you know that here cos alpha and sin alpha are constant. Okay? And you know the differentiation of cot x is minus cos x square x. Now within square root there is cos alpha plus cot x sin alpha. So this differentiation of cos alpha is 0 and differentiation of cot x sin alpha is constant, sin alpha remains as it is, sin alpha into what is the differentiation of cot x? That is minus cos x square x. हामीले माथिको भेट्टाउँदैछौँ. The sin alpha constant लाई यताउता मिलाउन सकिहाल्छौँ. That is differentiation of this denominator will be the numerator. But since I already told you that whenever the square root is in the denominator, you have to assume the expression within square root as z square. I already told you that, isn't it? So let us assume here, let z square is equal to, because it is on the root and that is also in the denominator. So we can assume let z square is equal to cos alpha plus cot x into sin alpha. Is that clear to all of you? So now let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what is the differentiation of z square? It is 2z dz by dx is equal to cos alpha, it is 0. Sin alpha remains as it is because it is constant and it is with the variable. Sin alpha into what is the differentiation of cot x? It is minus, what is the differentiation of cot x? It is minus cos x square x. So I think you have understood it. So let us cross multiply. Or 2z dz is equal to, this is your minus sin alpha into cos x square x, and this is dx. But in the numerator we have only got cos x square x dx. Let us get the value for cos x square x dx. Now minus sin alpha is taken to the left hand side. So what does it become? Minus 2z dz divided by sin alpha is equal to, this is cos x square x dx. So I think you have understood it. So let us put them in I, right? So therefore I is equal to integration of. Now what is cos x square x dx? The value for cos x square x dx is this one. So let us put it out here. Minus 2z dz divided by sin alpha whole divided by. Now it is root under z square, isn't it? What is root over z square? Z. Let us write here z, because root over z square will be there and root over z square is z. So here you can cancel this z. Let us cancel them. Or I is equal to, how much is that now? Minus 2 by sin alpha is constant taken outside. It is minus 2 by sin alpha, that is constant, it is taken outside. Okay. Then integral sign z gets cancelled. So it is only dz. Is that understood now? Now you can easily integrate them. Or I is equal to, what is this integration? Minus 2 by sin alpha into z plus c. And what is the integral sign dz? That is your z. That is minus 2 by sin alpha into z plus c. So let us put the value for z now. Or I is equal to minus 2 by sin alpha into, what is the value for z? Since here z square is equal to cos alpha plus cot x sin alpha. So what is the value for z? It is root over. It is root over what? If z square is equal to cos alpha plus cot x sin alpha, what is z is equal to? It is root under cos alpha plus cot x sin alpha. it is cos alpha plus it is cot x into sin alpha, isn't it? That is z is equal to root over cos alpha plus cot x sin alpha. Then what do we write here? Then you can write plus c. So this is the final answer. So I think you have understood it. So this question is very, very important. You can copy it. So I'll give you similar type of question. That will be your homework, right? So I'm giving you this homework. Let us write it as, this is 12 number 1, right? Let us write it as 12 number 3. You do it at home, okay? Homework. 12 number 3. This question is not given in a book, right? So integration of dx divided by within root, it may be cos cube x sine of x plus alpha. So what is the method here? You have to make it cos to the power 4x divided by cos x, right? Then what is square root of cos to the power 4x? It is taken outside. It is, you know that cos square x. And what is 1 by cos square x? It is sec square x. But you have to express that within square root in terms of tan x. You can easily do it, okay? Similarly, you can do this problem, right? And 12 number 4 is also your homework. Integral sine dx divided by within root. It may be sine cube x into cos of x plus alpha, right? And then 12 number 5, integral sine dx divided by within root cos cube x into cos of x plus alpha. So these are your homework, right? You sabai timako homework ho gharma garnu. This is also your homework. You can use the same method as we have done it here, okay? यहाँ के भन्नु पर्यो cos to the power 4x by cos x. This is sin to the power 4x by sin x. This is also cos to the power 4x by cos x. Then you can easily do it. You can use the same method as we have done it in 12 number 1. I hope you have understood it. Now we'll do the next problem. So now let us do this problem now. That is 12 number 2. Integration of sin x plus cos x divided by sin of x minus a dx. So let us write I is equal to integration of sin x plus cos x divided by sin of x minus a dx, right? Since there is x minus a out here, so let us write here sin within bracket x minus a plus cos of within bracket here also x minus a plus a, right? So that you can easily simplify it and then you can integrate it. So it is sine of, this is x minus a plus cos of within bracket x minus a plus a. This whole divided by, it is sine of x minus a. Then what do we write there? Dx. Now you should know the formula. Or I is equal to integration of. Now what is the formula that you can use here? This is your x minus a plus b. This is also x minus a plus b, because here it is sine of x minus a. So let us use the formula. What is sine a? Sine of x minus a cos b cos a plus cos of x minus a sine a. Understood? Plus. Similarly, this is sine a cos b plus cos a sine b, right? Similarly, what is cos of a minus, this x minus a is a and plus a is b. So this is cos of a plus b. What is cos of a plus b? Cos a cos b, cos a cos b. Then it is cos a cos b. Then since this is plus, it will be minus. What is cos of a plus b? Cos a cos b minus sin a sin b, minus sin a sine B. So I think you have understood it. So this is cos A means x minus A, cos B means cos A. Since this is minus, since this is plus, you should write here minus. Sine A is sine of x minus A and sine B is sine A. This whole divided by, what will you write? It is sine of x minus A. Then what do we write here? Dx. So you can write it within this second bracket. Okay. So let us separate the term now. Integration of within second bracket. Let us separate the term. This first term divided by denominator, sine of x minus A, will be cancelled. So it is cos A, right? So plus, next, cos of x minus A sine A divided by sine of x minus A. So it is sine A cot of x minus A. Is that clear? Plus, next, this one is cos A. Cos by sine is also cot of x minus A. This is cot of x minus A, right? Next, minus. I think I've understood it. Cos of x minus A divided by sine of x minus A is cot of x minus A. That is cos A is constant, minus. Here sine of x minus A will be cancelled. You will get only sine A. So here second bracket is closed. Then what do we write? Dx. We are just simplifying it. Okay? Or now I is equal to integration of within second bracket. Now you know that this cos A minus sine A is constant. You can write it within bracket. Cos A minus sine A is kept within bracket. Okay. And now here, what is common here now? Cot of x minus A is common, isn't it? So plus within bracket we have constant as sine A plus cos A. Here cot of x minus A is common. So within bracket sine A plus cos A. So we have cot of x minus A in this case. So it is cot of x minus A, second bracket closed, dx. I hope you have understood it. So this is cos A minus sine A is kept here. Plus from this second and third, what is common? Cot of x minus A is common. So within bracket we have sine A plus cos A, and this is dx. Is that understood now? So now we can easily integrate them. Or I is equal to, now let us separate the term. Cos A minus sine A is constant. Cos A minus sine A is constant. It is taken outside integral sign, then integral sign dx. Then integral sign dx. Is that understood? Then what comes? Plus sign. Plus sign, which is constant out here again. This sine A plus cos A is constant. It is taken outside integral sign. So let us write here plus sine A plus cos A. Right? That is your constant. Then integral sign cot of x minus A. Then integral sign cot of x minus A dx. So I think you have understood it. That means we are separating the term, and the constant term is written before integration sign. Okay? So or I is equal to, this is cos A minus sine A into, what is integral sign dx? You know that is, it is x, plus within bracket sine A plus cos A is constant. It is kept as it is. Now it is just like your integration of cot x. Here the power of x is 1. So x minus A is taken as x. So what is the integration of cot x? It is log of sine x. So here it is log of within mod. What is sine x here? It is sine of x minus A. So in this case, x minus A was taken as x, and then it is integrated. So it is log of sine x, right? So it is log of sine x. So it is log of sine x. But in this case, x is x minus A. Again, you have to differentiate the term which is assumed as x. So in this case, x minus A was assumed as x. You have to differentiate it. So what is the differentiation of x minus A? It is 1 minus 0, which is equal to 1. So in case of integration, you have to divide it by 1. So since it is 1, you don't have to write it. But in case of differentiation, you have to multiply it by 1. So This is the only integration out here, that is log within mod sine of x minus a whole divided by 1. त्यो 1 भएको कारणले गर्दा हामीले नलेखेको. Then we should write plus c. So this is the final answer. So I think you have understood it. Okay, so you can copy it. So this much is for today. त आज पनि हामीले जतिवटा प्रब्लम्स गर्यौं होमवर्क दिएको छु गर्नु घरमा बुझेन मलाई तिमीले कल गर्न सक्छौ हैन. You can ask me. So in the next online class we'll do more problems on this integration by the method of substitution from the same exercise 6a. So this much is for today.